Alright, hello guys. I'm going to be going over your third review for test number 3. So this will be covering the end of chapter 4 and then the parts at the start of chapter 5, uh, covering factoring. So you should have seen this in the study material I linked on Canvas. I linked you some material to study on this, so this should be related to that material. So this shouldn't be new if you looked at the links. Anyways, so the first two problems come from chapter 4, so we're evaluating a polynomial for x equals 5 and y equals minus 2. So let me zoom in actually, make it more visible. Yeah, so what it means by evaluating a polynomial for x equals 5 and y equals 2, or minus 2, is evaluating it for these variables means you're just plugging it in. So this is actually nothing new, but the problem is being given to you in a different way, and there's more than one variable. So what we're going to do is just wherever x is, we're going to put 5. And then wherever y is, we're going to put minus 2. So I like to use parentheses when I do this. That way I can keep track of which operation is needed to be done first. Okay, so 3 times 5 times y, which is minus 2. Okay, so all I've done here is substitute in the values. So now we just need to complete this and then just go through each one. So 5 to the second power is 25. Minus 2 times minus 2 to the second. Okay, so you have to remember here you have to do PEMDAS. So minus 2 and then exponent to the second power, you do the exponent first. So you do minus 2 times minus 2 squared. So minus 2 times minus 2 is positive 4. Okay, so then we continue over here. 3 times 5 times minus 2. Okay, well all of this is multiplication, so we can just go in order. So 3 times 5 is 15, and then times minus 2. Okay, and then let's finish it off. So this turns into 25 minus 2 times 4, which is 8, plus 15 minus 2, which is 30, so minus 30. Not sure why this minus sign is bigger than this one, but they're both the same thing. Okay, so 25 minus 8 is 17, and 17 minus 30 is minus 13. So our final answer for this problem would be minus 13. Okay. Number 2, this one says to evaluate the polynomial for x equals 2 and y equals positive 3. So same thing as the last problem. All we're doing is taking these values and plugging them in wherever you see the variable. So wherever x is, we're going to put 2. Wherever y is, we're going to put 3. So the first part is x squared, so we're going to put 2 squared plus 5 times y squared, which is 3, so 5 times 3 squared. And then minus 4 times x times y, so minus 4 times 2 times 3. Okay, so now we need to evaluate these numbers and see what they come out to be. So let's see, so 2 to the second power, that's just 4. 3 to this, okay, so now we have 5 times 3 to the second power, so we're going to do the exponent first because of PEMDAS. So we're going to have 5 times 3 squared, so 3 times 3 is 9, so we're going to have 5 times 9. And then the last term we're going to have minus 4 times 2 times 3, so it's just all multiplication. We can do it in any order really. So minus 4 times 2, minus 8 times 3. Okay, so we'll do that in a second. So now we're left with 4 plus 5 times 9 minus 8 times 3. So 5 times 9 is 45. 8 times 3 is 24, so it's minus 24. And now to complete this, we just have to put them together. 4 plus 45 is 49. 49 minus 24, that's 25. So 25 would be your final answer. Okay, number 3. Okay, so this is where chapter 5 begins. This is factoring. So this is the basics of factoring. So remember in your material whenever you studied it, it said factoring was when you try to find the common factor between the terms and then take it out. So what that means here is I'll re-explain it. So we have x to the third plus 6x squared. So we have to find the common factor between these two terms. So what's common to both of these? Well, x squared can be taken out from both of these terms, and that's about it, right? So x squared is a common factor in both of these. So I'll put this in parentheses to make it clearer. So this the common factor to both of these is x squared. So now if you take it from both of these, so if you take x squared from x to the third, what's left over is just x to the first. And then what's left over from 6x squared if you take away the x squared is just 6, right? So that's the basics of factoring. So your final answer when it says to factor is just these two factors being multiplied to each other. So x squared and then x plus 6, and they're multiplying. But you can just leave it like this. So we have our two factors, final answer. Okay. Next one says to factor, and it gave us 2t squared plus t. So we have to find a common factor between all of the terms. So these two terms have a common factor. So the only common factor I can see between these two is just the letter t. That's it. So I see t. Here, let's keep it lowercase. And then if we take t away from 2t squared, we're just going to have just 2t to the first. So just 2t. And then if we take t away from t, so remember, this isn't going to give you 0. If you divide x, like say you have x divided by x, you don't have 0, right? Something divided by itself will always give you 1. So t divided by t would give you 1, right? So if you take t away from t, it's like t divided by t. So you're going to be left with 1. So this is going to be 2t plus 1. So the same principle applies to the first term as well. So if you take t away from 2t squared, you're doing 2t squared divided by t, which gives you just 2t. Okay, so next problem is another factoring problem, but there's 3 terms in it. So we can still find a common factor between all 3 of the terms. So the first 2 terms have an x in them, so that would be a good start, but the last term does not have an x, so we cannot assume a common factor is an x because 15 does not have an x. So x cannot be a common factor. So now let's look at the numbers. Well, I see 6, I see 3, and I see minus 15. Okay, the common factor between 6, 3, and 15 is just the number 3, because 3 can be multiplied to get into each of those numbers. So 3 is a common factor. And then if we take 3 away from each of these, here's what we'll be left over with. So if you do 6 divided by 3, you're going to have 2, right? And then you still have your x squared. And then if you take 3 away from 3x, you're just going to have x, because 3x divided by 3 would be x, right? And then 15 divided by 3 would be 5. So you're left with minus 5. And that's it. So you would be done right here. Okay, so the next problem is factor by grouping. So remember, if you remember the notes on factor by grouping, you actually have to take it piece by piece. So factor by grouping is basically finding a binomial common factor, but there's a shortcut with a few of these problems. So if a factor by grouping problem looks like this, so there's an x minus 7 right here, and there's an x minus 7 right here. You already know the common factor on both of these two different terms is x minus 7, so you already have your first common factor right here, because both of these two terms in the problem have an x minus 7. So you can just take out x minus 7 as your first factor, and then your second factor is going to be composed of whatever's left over. So what's left over after you take away x minus 7? Well, on the left you have x squared left over, so we're going to have that. And on the right we have minus 3 left over, so we'll have that right here. And then you're done. So if a factor by grouping problem is formatted in this fashion, you can do this problem in about 3 seconds. It's really easy. So there will be 1 or 2 of these on the test, so knowing this shortcut for this problem will be useful. Just learn to recognize this. And then there's another factor by grouping problem, but it's not formatted like this, so you actually have to work it out a bit. So the trick with this one is that there's 4 terms, and there's a binomial common factor. So to get to that common factor, we need to organize the problem a little bit differently. So what you should do with this factor by grouping problem is divide it into two different terms. So the first term will be the first two terms together in one parentheses, and then the second term will be hold on, sorry. I was and this the next term will be the second two terms. So okay, so make sure you add between these so your plus sign didn't go anywhere. So all we did was put parentheses around the first two terms and then the last two terms. Okay, so now that we've done this, now we're going to treat each of these individually. So let's look at the first one, x to the third plus 2x squared. Okay, what's a common factor of x third and then 2x squared? That's what we need to ask ourselves. So a common factor between these two terms could be x squared. So let's take x squared. Here, let me make sure it's not capitalized. So x squared is a common factor, and then what we have left over if we take away x squared is x to the first, so just x, and then 2x squared. Oh, this will just be 2. So if you take away x squared from x to the third, just do division. So x to the third divided by x to the second will be x, and 2x squared divided by x squared will just be 2. So that's why these two terms are the what's left over when you take out their factor right here. Okay, so that's the first parenthesis solved. Now the second one. Okay, so on this one, we need to say what's a common factor between 5x and 10. Okay, well, a common factor between 5x and 10, well, this one doesn't have an x, so let's look at the numbers. So 5 and 10 have a common factor of just 5. So 5 can go into 5, 5 can go into 10. So 5 is a common factor. And then if you do 5x divided by 5, you'll just have x. And if you do 10 divided by 5, you'll have 2 left over. Okay? Okay, so on the next part of this problem, you're not done here. So our answer needs to be a binomial. So what's left over on this part of the problem is, well, you can just pretend that there's no parentheses here, but I only put it there for the sake of showing it's independent. So the next part of this problem that you should do is take what's left over on the outside. So on the outside here we have x squared and positive 5. So let's write x squared plus 5. And then what's left over is x plus 2. So another way you could look at this is that you could say, okay, so now we need to find a common factor between this term and then this second term right here. So a way you could look at it is say, okay, x plus 2 is a common factor of this term and this term. So you could say x plus 2 is a common factor, take it away from both these terms, and then what's left over? Okay, well, if what's left over here is x squared right here, and then over here what's left over is just positive 5. So that's assuming you take away x plus 2 from this term and this term. And this is what's left over. And then this would be your final answer, because now you have a binomial. So x plus 2 times x squared plus 5. Okay. Okay, eighth problem on the review is another factoring problem. So we saw one just like this earlier, so they're pretty similar. So just a common factor between 3t squared and t. So a common factor would be, well, just t, right? That's t is something that goes into both of them, so take out t. Now you have 3t squared divided by t. That'll just give you 3t to the first, or just 3t. So just write 3t. And then t divided by t, okay, well, that's just going to be 1 because it's something divided by itself. And then that's it. So this is what's left over. So t times 3t plus 1. Okay, number 9. Here, I'll move this on to the next page. So number 9, factor by grouping. Okay, so we did a problem like this just earlier on number 7. So we have 4 terms here, and it's factor by grouping, so we need to find out what our binomial common factor is going to be. So the first step in doing this problem is splitting it up into two different terms. So, or two different parentheses. It is probably more accurate. So the first parentheses is going to have 3x to the third plus 18x squared. And then the second parentheses will have the 6x plus 36. Okay, so we're going to start off by just splitting the first two terms and the second two terms up in their own parentheses. Okay, now we can treat them individually from each parentheses. So first set right here, 3x to the third plus 18x squared. We need to find a common factor between 3x to the third and the 18x squared. Okay, so looking at the numbers, is there a common factor between the numbers? So we have 3 and we have 18. Okay, well, the highest common factor between the numbers is just 3. 3 can go into 18 just fine evenly, so there's a 3. Now let's look at the variables. So x to the third and x squared. Okay, well the greatest common factor between the variables would just be x squared. So let's write that there. Okay, so now we have what's left in the parentheses. So 3x to the third divided by 3x squared. Okay, well 3 divided by 3 is 1. And then x to the third divided by x squared will just give you x to the first, or just x. So what's left over on the first term here is x. Now the second one is 18x to the second power divided by 3x to the second power. So 18 divided by 3, that's 5. Okay, so 18 divided by 3 is 5. And then x squared divided by x squared, right? Well, that's just 1, so you're left over with 5. So that's that part completed. Now, on the second one, we have a parentheses with 6x plus 36. So a common factor between these two. Okay, well let's look. This one has an x and this one doesn't, so x cannot be a common factor. But if you look at the numbers 6 and 36, these share a common factor of 6. So you can take out 6. So now 6x divided by 6 is just x. And then 36 divided by 6 is going to be 6. Okay, so that's that parentheses sorted out. And now, just like the other problem, we have to take what's left over for the binomial. So the last step, you can say, I think the easier way to approach this would be to just realize, oh whoops, sorry, I just noticed I made a mistake right here. So this was supposed to be 6, because 6 times 3 is 18. So let's just account for that. So it's probably easier in this step to just recognize that there's an x plus 6 in both terms and take that out as a common factor. So I advise doing that. So x plus 6 is one of the factors. And then the second factor will just have what's left over. So 3x to the second plus 6 right here. And that's it. So this is your final binomial, which is just factors that multiply to give you this. So one way to check your work on the test is if you have time or for some scratch paper, take your final answer right here and just multiply the terms together. So do this times this, and then see if this gives you what you started with. So this whole thing right here, these factors being multiplied to each other, these should equal out to whatever you began with. So just keep that in mind. So you can check your work. Okay, and then number 10. Okay, so 2x squared plus 2x minus 8, and it's telling us to factor. Okay, well, this is kind of similar to some of the other factoring problems. So we're just looking for a common factor between each of the three terms. Okay, well, the first two terms have a variable, but the last one doesn't, so x cannot be a common factor. But as far as numbers goes, we have 2, 2, minus 8. So a common factor between 2, 2, and minus 8 is just 2, right? So 2 can go into all these numbers. So 2 is a common factor. Now we do 2x squared divided by 2. Okay, well that's just x squared. 2x divided by 2. Okay, well that's just x. And then minus 8 divided by 2. Well, that's just going to be minus 4. And then you're done. So this will be your final answer. Okay, so this is your review. Good luck on the test, guys. If you have any questions, please email me or message me on Canvas or something like that. I know it was a little difficult learning online instead of being in person for the last chapter. Uh, Unfortunately, we could not control the corona situation, but I wish you guys the best of luck on the test, and I hope you guys succeed.